Welcome to the biggest plot twist in the history of particle physics: bismuth versus lead.
Remember my last video about ancient Roman lead? Well, there was one snarky comment. He asked, why not just use bismuth? Bi-210 has a half-life of only 5 days, right? We just wait, and the radiation goes away. This argument makes mathematical sense. Bismuth is often called green lead because it resembles lead but is less toxic. The isotope Bi-210, with a half-life of 5 days, practically eliminates radiation within a month. Although its decay product, polonium-210, has a half-life of 138 days, this material is considered clean within 2 years. Why don't we use freshly mined lead? The problem lies with Pb-210. This isotope has a half-life of 22 years. Too long to wait in a laboratory, but too fast to disappear naturally in mines. Until 2003, Bismuth-209 was considered the heaviest and most stable element. However, physicists in France discovered something horrifying. In 2003, a team from the Institut d'Astrophysique Spatiale proved that Bismuth-209 is actually radioactive. It emits alpha particles, although the probability of this happening is extremely small. Pierre de Marcillac and his team used an ultra-low temperature bolometer detector to detect the whispering signal from bismuth. Its half-life is 19 quintillion years, billions of times longer than the age of our universe. It's technically radioactive, but it decays so slowly that we won't notice it for centuries. Although bismuth decays very slowly, it emits an alpha particle with an energy of 3.14 MeV. For dark matter detectors, this is a fatal disturbance. A single alpha particle is like a cannonball in a supposedly silent room. This is why scientists are willing to dive to the bottom of the ocean to find shipwrecks. 2,000 years underwater is enough time for Pb-210 to decay to zero. We're left with material that's truly dead and doesn't even whisper a word. Let's look at the final shielding comparison. Bismuth-209 is metastable, emits alpha particles, and has low background noise but a whisper. Ancient lead is absolutely stable, emits zero, and is very quiet. Although it is extremely rare, it is available. This is why science is always fascinating. What we thought was stable for centuries is actually quietly decaying. And that's why bismuth is so far behind the 2-millennium-old Roman lead. Have any other questions? Leave your comments below. We'll choose one, and it might become our next content. Don't forget to subscribe for more in-depth science content. And let's grow together to create a better world for the future and for generations to come.